Hi everyone. Today we will see the working of a buck boost converter. It's a combination of step down and step up converter. Buck means it is step down and boost means it is step up. In the case of step down, your V output voltage will be less than input voltage. In the case of step up, V output voltage will be greater than input voltage. Here the output voltage will be always negative. You will see the circuit working. This is a circuit diagram for your buck boost converter. It consists of a switch. We can connect a MOSFET here. V input is given. One inductor L is there. Diode, capacitor and load resistor. Diode connection, it is in the reverse direction. That is, it will act like a freewheeling diode. We will see what will happen when the switch is in the closed position. So when you're closing the switch, this is the input supply. The current will be flowing in this path. That is from V input positive towards switch towards inductor positive towards inductor negative to V input minus. This will be the current path. As the switch is closed, the inductor's charge, the top polarity will be positive and the downside polarity, it will be negative. And what will happen when the switch is in the open position? So when the switch is in the open position, suddenly we are opening the switch. The inductor polarity will be changing. Here it will be negative and downside it will be positive. It will change the polarity and this inductor will act like a source. And the current flow, it will be always from source positive to source negative. So in this direction, current will flow. So this is the direction of current flow. So the output voltage will be negative in this case. Here it will be negative and downside it will be positive. And the current flow will be from inductor positive means L positive towards. So through capacitor path also current will flow. I am taking the load RL. So through RL towards the diode positive negative towards the inductor negative. So the diode connection was, we are connected the diode in this way, right? This was the diode connection. So when the switch was in the open position, we can see the circuit diagram. Switch was in the open position. Here it was positive. This positive is connected to negative of this diode. So the diode will be reverse bias condition. So when the switch is in the closed position, this was the diode position. So positive is connected to negative cathode of the diode. So your diode will be off position. And switch is in the on condition. And the inductor is charging. When the switch is open, the inductor polarity has reversed. Switch is off. Inductor has reversed this polarity. That means it is discharging. Whenever it is acting like a source, it will produce the maximum voltage across it. It is in the discharging condition. And the diode, here it is negative. The negative is connected to cathode of the diode. So the diode will be in forward biased condition. It is in the on condition. And this will be the current path, inductor positive to inductor negative. Next, we will see the output equation. So, for writing the output equation of buck-boost converter, we can use this voltage balancing theorem. Voltage balancing equation. That is V input, that is the voltage across inductor during magnetizing time into T on will be equal to voltage across the inductor during demagnetizing time into T off. So what is the voltage across the inductor during magnetizing time? Magnetizing means switch is closed, inductor is charging. So voltage across inductor during magnetizing time will be equal to, this is a closed circuit, the input voltage as such, it will be coming across this diode, this portion. This is not coming to picture, right? This is only coming to picture. So this is your circuit. So input voltage, it is a parallel circuit. You are considering this as an ideal switch. This will be, the input voltage is coming parallel to the output across this inductor voltage. So VL will be equal to V input. What will happen when it is discharging? What is the demagnetizing voltage? Consider this as an ideal diode. Drop is 0. So this is coming, this inductor is coming in parallel with this resistor, with this load. So what is the voltage across this load? That is V output. So during demagnetizing time, the voltage across inductor will be equal to V out. So we have got two equations. Equation 2, VL is equal to V out, that is demagnetizing time. And equation 1 is VL equal to V input, that is magnetizing time. So magnetizing voltage across inductor is V input into T on, that is equal to, during demagnetization, that is V out into T off. So we need to find the equation of V out. So V out can be written as, taking this to the denominator, V input into T on by T off. Here T on plus T off is equal to total time period T. So we need to take the T off in terms of T on. So T off can be written as T minus T on. So substitute the value here. V input into T on by T minus T on. So we need to take the equation in terms of duty cycle. So duty cycle is equal to T on by T. So we can divide the numerator and denominator by T. So divide the numerator and denominator by T. We will get the equation as V input into T on by T divided by T by T minus T on by T. That is T minus T on the whole by T. This can be written as T by T minus T on by T. So T on by T is duty cycle. So this will be written as V input into T on by T is duty cycle divided by T by T is 1 minus again T on by T is duty cycle. So this is the output equation. V input into duty cycle by 1 minus duty cycle. And you can check the values, whether it is stepping up, stepping down, how it is working. Suppose your duty cycle, we can take a value V input equals 10 volt. Suppose your duty cycle is equal to 50%. What is the output voltage? So V out is equal to V input, that is 10 volt, into duty cycle. In percentage it is 50%. So you can take it as 0.5. That is 0.5 by 1 minus 0.5. So 1 minus 0.5 is 0.5. So 10 volt into 0.5 by 0.5. That is equal to 10 volt. Here you can see your input voltage is equal to output voltage. In this condition, V input is equal to V output when duty cycle is 50%. That is, for a buck boost converter, when your duty cycle is 50%, V input and V output will be same. Next, we will take a duty cycle of 60%, for example, that is 0.6. So what will be your V out? V out is equal to 10 volt into 0.6 by 1 minus 0.6. So 10 volt into 0.6 by 1 minus 0.6 is 0.4. You can see here your V output is greater than V input. That is, when your duty cycle is greater than 50%. Here we are taken 60%. When the duty cycle is greater than 50%, V out will be greater than V input. Next, we will see duty cycle 40%. 40% means 0.4. So V out is equal to 10 into 0.4 by 1 minus 0.4. That is 10 volt into 0.4 by 0.6. So what will be the answer? It will be equal to around 6.6 volt. Here we can see V out is less than V input. That means when duty cycle is less than 50%, V out will be less than V input. These are the three conclusions of buck boost converter. So whenever duty cycle is equal to 50%, it is V input equal V out. Whenever duty cycle is greater than 50%, V output is greater than V input. When it is less than 50%, it is V out less than V input. So thank you all. We will see in the next video.